Okay, after using this formula, we convert x unit into z unit as you have seen in the previous slide. So here one more example. If x is distributed normally with mean of $100 and standard deviation of $50, the z value for x equals to 200 is given as follows by using this formula. So z equals to x minus mu over sigma, and x is 200 and mu is 100. We substitute sigma here and we can get z equals to 2. Now I give you some more examples. For instance, let's say mu is 10 and sigma is 2. We want to find different probabilities. I write some problems like x is less than 12 and greater than 8. Also, if x is greater than 8, and I write another one, x is less than 8 and greater than 6. I solve this first one. I try to convert this x unit into z scale. For example, uh, I say x1 is 8. This 8, I am saying it x1, and mu is given, which is 10. Sigma is 2. If I use z formula, because this is x1 and we can call it xz1, so x1 minus mu over sigma, 8 minus 10 divided by 2, so z1 will be minus 1. Similarly, we can find our z2 for x2. Now I am calling this x2 minus mu over sigma, so z2 will become 12 minus 10 over 2, which is 1. So corresponding to probability that x is less than 12 and greater than 8, our z unit was less than 1 and greater than minus 1. Similarly, if x is greater than 8, correspondingly its z unit will become greater than minus 1. Similarly, if x is less than 8 and greater than 6, its z unit will become z less than minus 1 and greater than minus 2. So this is how we transform x unit into z units. So now we write them in the standard bell-shaped distribution. So here in every problem we will draw this bell-shaped distribution. In the middle we always write our mu. Mu was 10, and the first problem was to find the probability that x is less than 12 and greater than 8. So we substitute x here. This is our x unit, and here in the bottom we write our z unit. Corresponding to this, our z unit came out. We just calculated it in the previous slide, which is this one. So x is 12, so 12 would be somewhere here and 8 would be here. So you can say this is x1, this is x2. Corresponding to this, z2 was 1 and z1 was minus 1. So we want to find area between x 12 and 8, so we need to find this area. So similarly we need to find this area, and we can likewise convert other probabilities onto this bell-shaped distribution, which was if x is greater than 8, correspondingly our z was greater than minus 1. So when we will transform it into the z scale, mu was 10, x is 8, so 8 will be somewhere here. Corresponding to z, z is minus 1. So we want to find area greater than 8. So here it is 8, so it means greater than 8 means we need to find this area. So we will find out area greater than -1. So similarly I can write the other one, the third question, which was x less than 8 and greater than 6. Corresponding to this, our z was less than -1 and greater than -2. So again we transform it into normal bell-shaped distribution. Mu was 10 and x is less than 8. 8 is here and 6 is here. We write both values of x here on the normal distribution and their corresponding z values -1 and -2. So this is the second step to apply normal distribution. So in the third slide I will show you how to see the area under the curve.